Hello and welcome to Business Reporter's Blockchain Campaign. I'm Alistair Greener and today I'm talking to Anna Backer from Jaroona. Good morning.
Good morning, Alistair.
So when we come to the blockchain, are the threats there, are they similar to the malware ones that we're all used to, or has it got its own whole new breed of bugs?
Actually, the blockchain inherits all centralized threats which are out there and adds its own vulnerabilities. When I'm talking about the centralized threats, what I mean is the known exploits in the implementation, the programming languages. There are lots of malwares which are coming up with 1 million new malwares per day. It's a known network attacks and the new one which are emerging. And plus, on top of that, the blockchain brings its own challenges of threats. There is a huge surface of an attack, of a penetration. If every smart contract is a penetration point, and you have like 1 million smart contracts running on the blockchain, it means you have 1 million penetration points.
It sounds like a huge threat. So maybe put it into some form of perspective. Could you quantify the security threat?
Yes, it's about $1 billion stolen from the blockchains in the first half of 2018 alone. To put it into perspective, last year in 2017, there was a devastating worldwide attack which was caused by WannaCry ransom crypto worm. It affected more than 200,000 computers across 150 countries. And it resulted in 130,000 ransom paid to the attackers. To get to 1 billion, it means that those kind of worldwide attacks should happen 40 times per day, every day for half a year.
Wow. I mean, that is a huge, huge problem. But the challenge is that we were promised that, with this whole system of blockchain, that this wasn't going to happen. We were going to get peer-to-peer viewing, so everything would become transparent. We would see if there was any problems, and therefore we would be okay. Is this not the argument?
Yeah, this argument is correct. The blockchain ledger itself is immutable. However, there are a smart contract layer which is running on top of it. So it's basically executable software which is running. Two major examples of that is 2016 is the DAO attack, and 2017 in November it's an exploit in the Parity wallet. So those were top developers, top in the industry who did it. So those smart contracts went through their, and the programming code went through their really extensive code review by the top national developers, and still it happens. And it will happen again because we are just humans, and we will continue making errors.
The thing is that when we look at all of these threats, that we look at the development of blockchain, and blockchain is trying to go fast. It's increasing its speed all the time. It wants to increase the decentralization, but it also has to stay safe and secure. And it almost seems that the safety and security element isn't really keeping up. So what's the solution? How do we make sure that it is safe and secure?
So the solution obviously is for every penetration point, put a separate decentralized defender who will be dedicated to monitor it and to make sure that when the attack is happening, everybody would be alerted before the damage is caused. Put there in an automated way so that those defender has some tools and detection models that would allow learning from the historical attacks and to find those patterns in real time and be able to defend it efficiently. And share this data. Share the data on the blockchain ledger itself, which is immutable and tamper-free, the data about backdectors, data about the exploits found, data about malwares, network patterns, collaborate with our cybersecurity experts. So those would be the defense mechanisms.
Tell us more about Jaroona in terms of how it works, and maybe some examples of it actually in practice.
Yes, so we actually offer this completely decentralized, distributed security nodes protocol. So it's basically a set of security nodes which are running on top of the blockchain and monitoring in real time, monitoring smart contracts, monitoring the underlying technology, monitoring the network layer to identify the problems, the threats, and alert the traditional peers when it's happening so that they can act on it before the damage is caused. The key component of our solution is that it's AI-driven detection model. We're using their supervised and unsupervised deep learning networks. We're using their boosting algorithms, bagging approaches, and others to be able to learn from the vast majority of the historical data, including centralized data, to be able to detect threats in real time. Another important part that we have an internal security ledger where we would write down their major information about the bad actors, about exploits, malwares, attack patterns, and that could be shared with the community and would improve the security drastically. So when I talk about the algorithms, I would like to emphasize that unsupervised and supervised learning enables a completely new way of finding the new emerging attack types or emerging malwares. Let's come back to the WannaCry malware, which has centralized components like the ones which would lock the files, and the other component would be the actual worm, which would enable the fast spread across the different networks. So to this one, the attacker on the blockchain would probably write a nice feature just to find out which wallets have a bigger gain to get, so that it attacks, first of all, those wallets. Those three components would not be recognized by standard signature-based or rule-based solution, but would be recognized by our solution, and the flag would be raised.
And tell us a bit more about those three layers and how that works.
Yes, every blockchain, the modern blockchain, except of course from Bitcoin and those categories, would have a ledger itself and would have a smart contract layer and would have a network layer, as all computers are open to the internet. So our solution offers the protection for the smart contract layer and for the network layer, so that this is happening in real time and this is being monitored in real time. Another important point which we offer is for the IoT networks. So if you have a layer of IoT devices which are low infrastructural devices, meaning that they cannot really run lots of software to protect themselves and are dependent on external upgrades, and we offer the solution that enables the manufacturers to place those security upgrades and verify them by our security nodes, so that their IoT devices would be actually upgraded on time and continue running.
It's really interesting hearing about the challenges that blockchain has at the moment. So it really begs the question, do you feel optimistic about the future of blockchain? Do you feel that it can be a really safe and secure platform for the future that we can all rely on?
Yes, I'm very optimistic because I also see that with the blockchain evolution, the blockchain developers and community understands a time-honored computer science principle. And basically what it says is that every solution layer has to do one job and has to do the job real well. When we're talking about blockchain, that job would be to keep the ledger immute and to protect it with scalable consensus algorithms, with efficient data sharing mechanisms. One very prominent CTO of the blockchain mentioned his blockchain would offer only bare bones infrastructure, pushing all complexity into the middleware layer, which opens the completely new way of services, which would be niche specialized, addressing the different problems the blockchain may face. One of those problems, of course, is cybersecurity. So this layer, solutions like ours, would be able to upgrade itself faster than the underlying blockchain, would be independent on that and would be able to react on security threats much faster. What we say is that you blockchain guys develop your infrastructure and we will secure it.
Well, we know that blockchain is very much here and now, and it's certainly going to be used a lot more in the future. So it's been really interesting to find out how the safety and security aspects of it are going to be met, and also to give us a lot more confidence in this new and exciting technology. It's been great finding out more. Anna Backer from Jaroona, thank you very much indeed.
Thank you very much for having me.